Welcome back to the course Mechanics of Solids. So, in the last lecture we were talking about the geometric compatibility, and based on that we were solving the actual problem. Like we studied, we generally study the force system, and then we study the deformation system, and then finally we try to bridge between these two, right. So, we'll take a couple of numerical problems today to understand this chapter or this topic in a better way. Okay. So, next problem, the stiff member AB is horizontal before the load of 5,000 pound is applied at A. So, I will show the figure later on. The 3 steel bars ED, BD and BC are fastened with pins at their ends. Find first the force in BD, and second is the horizontal and vertical movement of the point A. Now, let me draw the figure. Okay. So, this is the problem. So, the problem says the steep member AB. So, AB is a steep member, that means we are considering this member as a rigid member without any deformation. So, this member is not experiencing any deformation. So, it will be behaving as a rigid member. Okay. So, the steep member AB is horizontal before the load of 5000 pound is applied. So, before the application of this load at point A, this member AB remains horizontal. Okay. The three steel bars ED as shown in the figure, ED, BD and BC. So, they are all two force members. Okay. So, are fastened with pins at their ends. Okay. Find first the force in member BD, okay, and the second the horizontal and vertical movement of the point A after the application of load 5000 pound. Now, what will happen if you apply the load here? So, it will try to rotate with respect to these points, right, because AB will not be deforming at all. So, if you try to draw the deformed shape, so it will how it will look like. So, let us draw that first. So, geometry of deformation. So, let me draw it. Okay. So, the probable deformed shape will be like this, because you are applying some 5000 pound load here, right. So, now if you look at this figure, so how I mean if you want to find out the deformation or the movement. So, AEB rather, okay, that was the stiff member. Now, that is taking the position like A prime, E prime, this is your E prime, this point is E prime. So, A prime, E prime, B prime, okay. And so, you are just observing some rotation here, right. you are observing just rotation here, and of course, some deformation in the steel members will be there based on the member force, right. So, if it is compressive, then it will be compressed, it will be, if it is tension, then it will be elongated. So, based on the member forces, okay. So, these members will be deforming. Now, this B point basically goes to B prime point. So, this is the point. So, therefore, you have the vertical movement of B point is given by delta BV, which is the vertical distance between B and P prime. Similarly, the horizontal distance between B and B prime is your delta BH, that is your horizontal movement of point B. Similarly, delta EV is your vertical movement of point E, and delta EH is the horizontal movement of point E. Likewise, delta AV is your vertical displacement or the movement of point A, and delta AH is the horizontal movement of point A. Okay. So, this is your probable deformed geometry. Now, if you try to find out the free body diagram of the system, so if I want to draw the free body diagram, what should I do? I should remove these supports with the reaction forces. So, now as I told you, this BC is the two force member. So, therefore, the reaction which will be developed at point C, that will be simply vertical. So, we are not going to discuss much about this, because already we have discussed in detail regarding this, I mean why you will be getting only the vertical reaction. Okay. So, that I am saying say RC. Similarly, at point D you will be getting RD, though you are having two different members ED as well as BD, which are connected at point or the joint D, still you will be getting only the vertical force, because you do not have, if you suppose if you apply some horizontal reaction here, suppose if you can have some horizontal reaction. Okay. Now, which force will take care of that horizontal reaction, because there is no horizontal reaction at C to take care of that, and there is no externally applied horizontal force also. So, if there is no horizontal force in the system, then you do not expect some horizontal reaction which will be developed. Okay. So, therefore, at D also you will be having only the vertical reaction. Fine. So, with this system we can solve for the unknown reactions. If you solve the unknown reactions, then basically if you consider summation of all the forces in y direction. So, if it is my y and x direction, this is my x and this is my y, and if it is not mentioned, every time I am not going to mention this, if it is not mentioned, so it will be taking the same direction like x and y. Okay. So, summation of f and f y equal to 0. So, if I do, so what are the forces are acting? So, RC plus RD minus 5000 equal to 0, right. This is my equation 1. Similarly, I can take moment equilibrium with respect to point D, right, summation of all moments with respect to point D equal to 0. That gives me RC into 6, because this distance is 6 feet, okay, plus 5000 into, okay. So, RC will be giving me the anticlockwise moment. So, RC into 6, and 5000 pound also will give me the anticlockwise moment 5000 into 12 feet. So, from this I will be getting RC equal to minus 10,000 pound and RD equal to, and RD equal to 15,000 pound. Okay. So, these are your support reactions. Now, if you look at the magnitude of support reaction, so RC is coming minus 10,000 pound. So, 10,000 is the magnitude. Now, what is the minus sign? As I told you, because I was not knowing what should be the proper direction or the actual direction of RC and RD. So, I considered RC as well as RD both are in the positive y direction, that means upward direction. But now, after calculation, it comes that RC is negative 10,000 pound, that means the actual direction of RC is downward. I need not to consider or need not to assume anything, or I should not have any preconceived notion that what should be the direction of RC and RD. Automatically it will be coming from the calculations. Okay? Well, so RC is actually acting in vertically downward direction, whereas RD, the direction of RD is perfectly fine. Okay? Fine. Now, with this, so I will keep this figure because I need this. Now, if you consider considering joint C, if you consider joint C, RC is acting. Now, RC I can show vertically downward. So, RC which is equal to 10,000 pound, and what is acting? The member force in BC is also acting, right. So, I am showing a BC which is coming away from the joint. So, that means we are considering tension. Still I do not know what should be the direction of ABC, or what should be the sign, I mean tension or compression, that I do not know. Anyway, so that will be coming from the calculation. So, from this I can simply write ABC is equal to RC equal to 10,000 pound, right. If you consider summation of Fy equal to 0, if you satisfy that condition at joint C, you will be getting that. So, from this what we have got? We have got whatever direction of ABC we considered before the analysis, that was perfect. Okay. So, we have got ABC equal to 10,000 pound. Now, if you consider joint D, if you consider, so at joint D, if you draw the force vectors, this is your RD which will be in the upward direction. Okay. Now, I am considering this is my FDE which is towards the joint. So, I am considering FDE as compression, and then FBD, fine. So, these are the forces are acting at joint D, okay, and this angle is 45 degree, whatever. So, now if you try to find out the forces from this force vector or force diagram, so what you will get? You will get simply FBD equal to 0, okay, and FDE equal to RD equal to 15,000 pound. Now, you have got all the member forces, right. Now, in the first part of the problem it was asked that what is the force in member BD. So, that you have got what is the value of the force in member BD, simply 0. So, member BD, okay. So, I forgot to draw here. So, of course, this is connected by this and this will be connected by this. Okay. So, anyway, so that is not a problem. So, it is quite understood that those members are there. So, member BD is not carrying any force. If it is not carrying any force, then what you can conclude? There is no deformation in that member. The deformation will be happening only if the system is carrying some force. If member BD is not carrying any force, then there is no deformation in member BD. If there is no deformation in member BD, then BD must be equal to B prime D, right. If member BD is not carrying any force, then member BD, the length of member BD must be equal to the length of member B prime D. Okay. Now, if it is so, then what we can write as, because member BD is not carrying any force. So, length of member BD must be equal to length of member B prime D, and similarly BE must be equal to B prime E prime. Why it is so? Because we considered this AEB, this member, as a stiff member. So, if that is a stiff member, then there is no deformation. So, length of BE before deformation must be equal to length of B prime E prime even after deformation, because there is no deformation happening in that member, but that is the stiff member. Okay. So, from the deformed geometry, if you look at this deformed geometry, so this BD and this B prime D both are equal, and if I consider a small deformation problem, so basically what is happening, this member AB, okay, this stiff member AB is just rotating with respect to point D. Try to understand. Member AB, that stiff member, is just rotating with respect to point D. So, basically from B to B prime you can consider a circular arc. So, that rotation is happening, and BD or B prime D, that is nothing but the radius, okay, because they are equal. So, from that we can simply establish this geometric compatibility or the fit delta BH must be equal to delta BV. Okay. So, something like, so this circular rotation is happening. So, whatever amount of vertical movement is happening at point B, the same amount of horizontal movement is happening at point B. So, delta BV is equal to delta BH. So, now what is the value of delta BV? So, delta BV we need to calculate. Now, if we want to find out delta BV, basically delta BV is nothing but the elongation of member BC, because delta BV is in the vertical direction, member BC is also a vertical member. So, the amount of elongation happening at member BC is equal to the vertical movement of point B. So, delta BV can be calculated as FL by AE of member BC. F is the force in member BC, L is the length of member BC, A is the cross sectional area, everything is given in the problem of member BC, and E is the elastic modulus. You know all those things. So, if you put all the values, so 10,000 pound is the force carried by member BC into length of member BC is 6 feet. So, 6 into 12 is nothing but the inch. So, 72 inch. Okay. So, I am doing this problem in FPS unit. that does not matter whether you do in FPS or SI, you have to consistent with your, you have to be consistent with your unit system. Okay. And then area is given 1 inch square into 30 into 10 to the power 6. Okay, that is the E value. So, that comes around 0.024 inch. Okay. So, now similarly I can calculate delta EV. So, I can calculate delta EV because ED or DE, whatever you say. So, DE member is a vertical member. So, and DE member is under compression, already we have seen. So, the amount of compression happening in member DE is nothing but equal to the vertical movement of point E. So, delta EV can be calculated as FL by AE of member DE. So, if you put all the values, you know what is the magnitude of force carried by DE, that is 15,000 pound, and if you put all the numerical values, you will be getting 0.018 inch. So, this sign is for inch, I hope you know that. Okay. So, double dash. Okay. So, I have got delta BV and delta EV. Now, to become BE equal to B prime E prime, I have delta EH is equal to delta BH, okay, is equal to delta BV is equal to 0.024 inch, already calculated. Delta EH, what is delta EH? That is the horizontal movement of point E. What is delta BH? That is the horizontal movement of point B. So, they must be equal, otherwise you will not be getting BE equal to B prime E prime. So, once I say BE is equal to B prime E prime, so same amount of horizontal movement should happen in the member AB. So, the amount of horizontal displacement the B point experiences, the same amount of horizontal displacement E point should experience, and A point also. Okay. And of course, delta BH must be equal to delta BV, already we have established from the geometric compatibility. Okay. So, now if we can write that, then of course, we can write similarly delta AH, that is the horizontal movement of or horizontal displacement of point A, must be equal to delta EH, because AE is equal to A prime E prime, okay, is equal to since AE is equal to A prime E prime. So, what we have got? We have got the horizontal displacement or horizontal movement of point A, which is nothing but 0.024 inch. Now, we need to find out the vertical movement of point A. So, in the next lecture, we will talk about or we will try to derive the vertical displacement of point or vertical movement of point A. Thank you very much.